Okay, today's last lesson is on solving radical equations. So what we're going to be looking at is a square root equation, not a graph or a function, and we're going to be looking for what is the solution of that equation. So the biggest difference is our equation will be given to us instead of as being y equals, it'll be usually 0 equals square root of some number or something along those lines. So you'd have some sort of equal to a number or equal to x or whatever. So the first thing we want to do, we're going to look at solving these things algebraically, like just rearranging equations and solving it like you normally would. What we want to do is be able to do the restrictions on the variable. Because we're dealing with a square root, we cannot have the square root of a negative number. So that means the square root has to be 0 or bigger. Okay, so whatever's under that square root sign has to be a positive. So as long as it's not a negative, we're good. So then once you have your equation, the idea then is to make sure you isolate that square root. So we want to have it so that we have some sort of square root equal to whatever else of the equation. So it could be just a regular number like 4, and we just square root both sides. It could be an x. So when you square both sides, you have to be careful with that. And then after that, you just solve it, and then always make sure you check your solutions. When we're dealing with square roots, quite often we get answers that are not valid when you plug them back in. So we'll go through a couple examples looking at that. So here's this first example. The first thing is we want to figure out what the restriction is. So for the restriction, we want to make sure that 12 minus x is greater than 0. So you can either just solve that equation or use common sense, right? If we just use common sense, 12 minus 12 would be 0. So as long as our number is less than 12, we should be good. Or if you want to rearrange and solve this equation, bring the 12 to the other side, divide by -1. When you divide by -1, remember the radical sign flips. So that's how we get the x is less than 12. Now we want to get the equation isolated, so bring the 4 to the other side. So when we bring the 4 over, it becomes just 3. Square both sides, so we get 3 squared is 9, and then the root goes away. And just solve the rest, bring the 12 over, so I'd give you -3 equals -x. Divide by -1, and we get x equals 3. So in this case, we have one possible answer. So now what we want to do is just do a quick double check, plug in that 3 to see if it works. So 12 minus 3 plus 4, 12 minus 3 is 9, square root of 9 is 3, 3 plus 4 is 7, we're good. So that means that x equals 3 is a valid solution. So now, if you're going to do a question where you want to try just solving it by graphing, it also works. And there's a couple different ways to graph. The first method is rearrange the equation so that it's equal to 0. So in this case, we've got this x plus 6 on the other side. So if we move those over, we'd have minus x on the other side, and then our 2 minus 6 gives us minus 4. And then once you have that equation, you're good enough to graph. So just plug that in on your calculator, graph it, and it gives you an equation or a graph that looks something like that. So from the graph, all we do is find our x-intercepts. You can see it's at -3. So now if we plug in -3 into our equation, it does indeed work out. So -3 is a valid solution. What we want to be careful of, though, is a question like this. So let's leave it back in the original form if we had it as equal to x plus 4 on the other side. Let's solve this one algebraically. So if we square both sides, you'd have x plus 4 under the root, but then we'd also have x plus 4 on the other side squared. So make sure when you do that, you got to FOIL that out. That x plus 4 squared means x plus 4 times x plus 4. So when you FOIL that out, you should get x squared plus 4x plus 4x plus 16. And then simplify all that, give you 8x plus 16, and then let's bring everything over. So minus the x would give us 7x, minus the 4 would give us 12. So we end up with a quadratic, and then once you have a quadratic, you can either factor it, use the quadratic formula, use a solver in your calculator, whatever you prefer. But in this case, it's pretty easy, so let's just factor it. So we should get plus 4 and plus 3 to multiply to give us 12, but add up to 7. So therefore, we get an answer of -4 and -3. So with the -3, we already got from the graph. We know that one's good. But what about the -4? So if we plug the -4 back into the original, we'd have root -4 plus 4 And then we'd have minus -4, -4. So that gives us 0, plus 4, minus 4 equals 0, which is good. 0 equals 0 is good. So they're both valid answers, but on our graph we only saw the -3. So you can see where -4 is actually right where the quadratic actually starts. So the -4 is indeed a valid answer as well. So you got to be careful with graphing because you won't be able to get that point on your calculator. It won't give you that intersection point because it doesn't go below. And your calculator always asks you to do the left and right of any kind of intersection point. So if you do see one like that, you're probably better off to do the math algebra way of solving it just in case so you don't miss out on that extra one. Okay, the second way of doing these questions is to just leave the equation the way it was and then graph both sides. So you type in y equals 2 plus x root x plus 4, and then do another equation y equals x plus 6, and you get our two equations. And in this case, our intersection of the line occurs at -3, 3. We only worry about the x-coordinate, so that's where our -3 came from in the last question. But we also saw that the -4 was a valid answer, and we can see that on this graph at -4, 2, there was also an intersection point because that's where the red one starts. So once again, we need to have both equations. And I'm not sure if your calculator can handle that intersection point or not. It might not. So once again, for these kind of questions, if you're not sure from the picture, solve it by algebra just to be safe. Okay, so here's one. Let's do a different question where we're going to solve it both ways. So algebraically, first off, let's get the -3 to the other side. That'll make a +3. Let's divide by the 2. So 3 divided by 2 is 1.5. Now let's square both sides. So we get x minus 4 equals 2.25. And then add the 4 to the other side, so we get 6.25. So you can see mathematically we get x equals 6.25. If we plug it back in, it indeed does work out. And alternately, if we graph it now, if we actually graph this original, it's equal to 0, so we might as well just leave it equal to 0, and we can see our x-intercept is at 6.25. So it's a good way to verify is to do both. If you solve it mathematically, still it doesn't hurt to put the graph in just to make sure that it is indeed the same point. Okay, let's try another one. So here, let's bring the 3 to the other side. So we have x minus 1 equals x minus 3. Now we need to square both sides. Remember, do the whole thing. So we'd have x minus 1. When you FOIL out the x minus 3 times x minus 3, we'd have x squared minus 6x plus 9. I simplified the in-between steps, but just make sure you write out twice, FOIL out all the combinations. Let's make this equal to 0. So we'd have x squared minus 7x plus 10 when we bring the 1 over. This one will factor into minus 5 and minus 2. So our solution should be 5 and positive 2. But once again, let's double check both of these. So 3 plus 5 minus 1 equals x, which was 5. So we'd have 3 plus root 4 equal to 5. 3 plus 2 equals 5. That one's good. So x equals 5 is good. Let's try the 2. So 3 plus root 2 minus 1 equals 2. So 3 plus 2 minus 1 is root 1. So that's 3 plus 1, which equals 4, not 2. So that one's no good. So we'd say that this 2 is extraneous. So that means we only have the one solution. And if we were to graph that one, we would see that it only crosses in one spot. Okay, the last one, let's graph this one. Because we got two equations, let's try graphing it as two separate equations. So on your first one, let's put in x plus 4. So x plus 4 rooted plus 4, so 4 plus root x plus 4. Let's graph that one. So we end up getting a curve. It's crossing at 1, 2, 3, 4, 5, 6. So it's crossing about here. That's making sort of a quadratic graph, something like that. And then for our second equation, let's graph x minus 4. And that one will be straight line that goes through -4 and 4, so something, here I'll do this one in a different color, so it'll be some sort of line like that. So on your calculator, just make sure, if you need to zoom out or in or whatever, to make sure you see that intersection point. And once you have it, so in this case it looks like it's crossing, somewhere in there. My graph isn't too accurate, but close enough. So let's just go second calc intersect on your calculator, and we should be able to find that intersection point. And the point works out at 12.8. So I'm off a little bit on my graph. 12.8 is about there. So my lines are a bit off, but good enough. So on your calculator, just graph the two, find the intersection point. We get 12.8. And we only want the x coordinate, so x equals 12. If you see an intersection point on your graph, that is the actual answer. You don't need to verify it, but you could if you wanted to. You could plug the 12 back in, and it does indeed work out. And that's all for this stuff.